Hello everyone, welcome to the purple classes of the Rus Indica IAS Academy. Desh Badla, Padhai Badlo. Today we will be discussing about the in the Indian economy the different type of irrigation and irrigation system storages. So it is yet another very important topic as per the GS paper 3 of the UPSC mains exam is concerned. So I hope all of you are going through lecture by lecture, topic by topic. That is the way I'm covering the whole syllabus for all of you. So I am covering all the static portion along with some recent question answers that has been asked in the UPSC mains examination so that you can become well versed with like what exactly the questions are like from this topic, what type of questions can be framed, and how you are going to attempt that questions, right? So before attempting or before analyzing anything, everywhere it is said that you should have a static component always. Static component always has to be there. Okay, that static component has to be supplemented with current affair, or we call it as a dynamic part of the paper, and then this is how it is helpful in providing you a holistic answer. It will provide you with holistic answer. So that is why we are covering all the static portion right now, because people normally go and see the syllabus, but actually they directly jump onto the current affairs. They think that the question will be always related to current affair, but they don't understand that foundation has to be on static basis. If you don't know the static portion of that topic, how you are going to relate it and how you are going to link it with current affairs, right? So static is the foundation. Static is the foundation above which your answers will be built. You will be supplementing your static content with the current affairs, and then only it is going to be a holistic answer, right? So today topic is different type of irrigation and irrigation system and storages. So irrigation means related to water, right? So let's go and dive into water first. Okay, so this is the syllabus part. Different type of irrigation and irrigation system and storages. Okay, water. Why we are talking about the water? Water is everywhere, but the major importance of the water everybody knows, like where it is required. It is for drinking, it is for sanitation, it is for agriculture. Because if agriculture, if we don't have water, agriculture will not be able to sustain on the earth's surface, and if agriculture is not there, then the human life, then humanity will not survive on the earth's surface. So this is the most important component, and whenever we go and search for extraterrestrial bodies, planets and various other things, we always want to find out whether they have any water or not, because that is the main uh, link between the life and non-life things. Okay, so water needs to be applied on the crops in an exact amount and on a proper time. That is why irrigation becomes important. So whenever we say irrigation, that doesn't mean that something is falling like from the rainfall that is falling on the earth surface. We call that as irrigation. That is rainfall. But irrigation have a different meaning. Irrigation is the artificial supply of water to the crops for the purpose of agriculture production. Okay, you cannot control the rain, right? But yeah, we can control the irrigation. We can increases, we can decreases, we can slow it down and everything. So that is why irrigation is the artificial supply of water to the crops. Okay, artificial means are lot of means are there. Artificial means your canals are there. Artificial means your wells are there. Artificial means your tube wells are there. Tank systems are there. Okay, these all infrastructure facilities help in transportation of water from one place to the other for irrigation need. They take the water from the river, they take the water from the ponds, they take the water from the underground water, and then they deliver it to a particular location, that is called irrigation, that is artificially supplying of water to the crops. Now, why water is essential? This is like very fundamental. Water is essential because it is used for drinking. Without drinking water, our body will not remain hydrated, and our body will not able to function properly because 70% of our body is water. Agriculture most vital. Agriculture is only dependent on water. Rest other things can go ups and down, but if water is not there, then agriculture will not be sustained, because that is why agriculture utilizes a significant portion of the water, right? Industrial process, there is no industrial process which does not require water. Every industrial process, whatever the work they are doing, at any level they are doing, they are requiring water, whether in manufacturing, whether in cooling, cleaning, transportation, etc., etc. Water is needed for energy production, very important. Wherever you go, thermal power, nuclear power, right? Hydropower, everywhere water is needed to convert into the steam. Kinetic energy of the water, that is steam, is utilized for the running of the turbines. Cooking and food processing. Obviously, without water, you cannot expect any type of cooking or any kind of food processing. Sanitation and hygiene, obviously, water is the main source of that. Okay, whether you are bathing, whether you are washing clothes, cleaning your surfaces, or whatever it is. Recreation activities, people go to swimming pool, leisure activity, people do diving, high jumps into the water, floating, fishing, everything. These are the recreation. That means a kind of a sporty nature of a water, like how you are going to utilize water in a sporty way, right? That's what I wanted to tell. Then water is the major component for ecosystem support, aquatic ecosystem, terrestrial ecosystem, air ecosystem, whatever it is, habitat. Wherever you go, ecosystem support, water, clean water, and proper water supply is very, very important for ecosystem support. Okay. So, after that, what is a need of irrigation? Why exactly we need irrigation? We have a rainfall, right? Why we need the irrigation part then? We need irrigation because there is a water scarcity throughout the world. The lakes are drying, the rivers are drying, the groundwater reservoir is depleting, and we don't have sufficient water that is coming from the rainfall. Climate variability, we know that every year there is a shortage of rainfall. Sometimes we have a high rainfall, sometimes we have a low rainfall, sometimes we have a El Nino situation, we have sometimes we have a La Nina situation. Okay, so climate variability is so high and it is highly unpredictable, and it because of that we have a irregular rainfall that is happening everywhere. Okay, but in our country, two-thirds of the farmer totally rely on the natural precipitation, that is rainfall. So that is why irrigation is needed in order to provide water to the crops, so that crops do not get destroyed just because they are water deficient. Increase in agriculture productivity, proper supply of water at proper time lead to agriculture productivity. If you are providing proper irrigation, farmer can get higher yields just because they can utilize the water at particular time. Okay, they don't have to depend on the erratic nature of the rainfall. And if proper irrigation is there, then crop diversification will be also done by the farmer, because farmer is sure that yeah, I will be getting water through various sources, so I can do various type of crops, and I can sow various type of crops in my field. And if the water weather system is not good over there, so local supply of the water either from canal, water tank, whatever it is, you can provide. Okay, so proper irrigation also help in promotion of agriculture diversification. It also, if irrigation is needed because it mitigates the extreme weather event, even whatever the extreme weather events are there. Because if there are too much extreme weather events are there, like floods are there, heat waves are there, all of a sudden dry spells are there, totally drought has been there. So we have irrigation methods, we have tanks, we have canals, we have everything is there. So it keeps our mind intact that even whatever the weather patterns is there, whether the weather patterns are change or not change, we will be having water for our irrigation need. Supporting rural livelihood, okay, because agriculture is the primary source of livelihood in the rural areas, right? So if we keep on providing year-round water facility, okay, it helps in generating employment. Irrigation is needed so that their field remains full throughout the year. It is not like that they only depend on rain. If they are having good irrigation facilities, so they can grow two, three types of crops. So the people will get employed throughout the year, right? And it will also help in boosting the income of the farmer. Water, energy, and food nexus. Irrigation plays a very interconnected role between the water, energy need, and food system. They are all interlinked together, right? Because we need electricity for pumping and distributing water, and agriculture is the major user of the water. So that is why we need proper efficient irrigation practices and proper optimization use of the water and energy resources. So irrigation is needed, because if we have a proper irrigation, then we can be properly utilizing our crop, we will be properly using it for generation of energy, we will be also be generating proper food for and help in food security, it help in food security, right? Then environmental conservation. So irrigation may have environmental impact, because if you are taking out too much of water, then it will automatically deplete the water, like groundwater sources, and sometimes too much water extraction, it may lead to soil salinization also. So this will lead to like environmental degradation. But if you are not managing it proper, but if you are able to manage it properly, then it will lead to environmental conservation, because you will be efficiently utilizing the water and you will be reducing the reliance. That is why irrigation is needed, because we have to reduce our reliance on the natural sources of water like precipitation, and with this we will be helping in saving the biodiversity. Because if the area becomes dry, if the area becomes dry, automatically the biodiversity of that area will die. So irrigation is also needed in order to preserve the biodiversity. Then global food security. We are facing the whole world is facing the food security outage. So if proper and better irrigation facilities are being provided, then it is to a larger extent that we will be solving the issue of food security, because demand of food is increasing day by day. Similarly, we have to also increase our production of food day by day. So for increasing the production, we need to irrigate the field in order to increase the production and in order to have a stable supply of the food. So that is also one more important thing why I need irrigation. Okay. Now we will be now discussing different type of irrigation system. So our whole India, 36% of the net sown area is irrigated. 36% of the net sown area is irrigated, and rest is dependent on the rainfall. Rest is dependent on the rainfall. So that means it is a very, very low percentage of area which is irrigated in our country. So there are a lot of systems that are in place, and there are various ways at different parts, because we know our India is a very diverse country, have a very different geomorphological features. North India is different, South India is different, Northeast India is different. So everywhere people are utilizing different irrigation techniques based on their local climate, local uh, uh, earth and all this. Okay, so the main goal of irrigation, what exactly is the main goal of irrigation? To supply the entire field with uniformly with water, so that each plant has the amount of water it needs, neither too much, neither too. So this is the main goal or role of agriculture that we wanted to do. Irrigation system based on source. Source means the way irrigation water is conveyed to the head or the stream point of a field. Like if this is our field, if this is our field area, so outside the field, what is the thing through which the water will be coming? Okay, that is the head or the upstream. That is the head or upstream. Okay, so that can be maybe from tank water it is coming, maybe from the wells or the tube wells might be coming, either it will be a canal irrigation. Then some people will say, sir, we can get the electricity from, we can get the water from the dam, we can get the water from the river. So my question is, do you bring whole dam water to the field direct? Do you get the whole river water to the field direct? No. Dam provide you with channel. Channel will be your canals. River will provide you with channels. Channels can be your canals. And these canals will be coming as a head stream in your fields. Right? So, based on the sources, we have a tank irrigation, well and tube wells, and canal irrigation. So, we will be discussing each and every one of them in a proper detail. So, first we are moving towards the tank irrigation system, right? So, it is a very, very old method, very, very traditional method, centuries old. If you go to the temples areas, if you go to the temple area and if you go and find over there, every temple, if you, it is most visible in South India. Okay, all temples have a very, very large tanks. Even the palaces of the kings and queens and whatever it is, they have a high, very big, big tanks. Okay, baulis are there. Okay, so tanks are built at a places where water resources are very, very limited. Water resources are very, very limited, and because they do not have proper way to store the water, so wherever the modern technologies of irrigations are not there, so wherever the modern technologies of irrigations are not there, especially in the rural area or the remote areas, okay, very, very remote areas, is still people are practicing the tank irrigation to a very, very larger extent. Okay, because they are not having any modern technologies, they are not having modern irrigation systems, so people are utilizing this tank irrigation systems right now, and they are widely used in southern India, even in northern India and eastern India widely. So let's see some definitions and concept related to this tank. So what is the exactly meaning of a tank? Tank is just like a small and medium sized reservoir. Okay, it is not a very big thing that we can. It is a small and a medium sized reservoir where it will capture the rainwater, store rainwater or storm water whenever there is a monsoon season or any rainfall happens. So it collects that water in the tank. Okay, normally it is consist of earthen embankment, so it is made from the earth only, right? It's just like a very big earthen pot kind of a thing. Okay, or you can utilize a natural depression, okay, in the land area. Like if you have a plain area, all of a sudden you have certain depression in the land, so you can convert this area into a tank. You call this as a tank, and then you can store the water over here by just doing some kind of cementation and all these things. Okay, so water will come, the water will be stored for the future use whenever there is a shortage of water, wherever there is a lack of water during the dry season, the water from this will be used for irrigation purposes. Right, so tank is a reservoir where rainwater is stored. Then Along with a tank, there is a word that is called catchment area. Catchment area means if we have a tank over here, okay, if we have a tank over here, and the water is flowing from here, the water is flowing from here, the water is flowing from here. So we call this whole area as a catchment area of a tank. From wherever the rainwater is getting collected in that tank, we call that whole area as a catchment area. Okay, similarly, rivers are also having the catchment area. Rivers are also having a catchment area. That means from where the main river is passing and where all its tributaries are joining. So this whole area, river along with its tributaries, are called as a catchment area of that river. So you all got the concept of the catchment area. Then we have a inlet channel, like from where the water we directs the water from the catchment area to the tank. So these are all the inlet channels. These are the inlet channels that are moving towards the tank. Okay, and then we have a outlet channel. Like so, inlet channels are there. And now from where we will be utilizing the water, like how we are going to use the water from the tank, that is called outlet channel. And then we have a sluice gates. Sluice gates means we can control the flow of water in and out of the tank. That means you sometimes you have tank full, so you close the gate. Sometimes you have less water on the tank, you open the gate of the tank. Okay, like so automatically water start getting filling from there. Okay, so that is the gating system. You see in a dams, in the dams, if the dams get full, they open the gates, and if the dam is low, they close the gates. Okay, then canals and channels, that are the network of waterways which is help in distributing water from the tanks to the fields. So this is what the total concept and key components related to this whole. Now, what is the importance of tank irrigation system in India? Obviously, they play a very important role wherever you go, because they are the very important source of irrigation where we have an erratic nature of rainfall. That means sometimes rainfall is happening, sometimes it is not happening, sometimes it is not happening up to a sufficient amount, right? Or you are not having surface water proper, like no proper river supply is there, no proper canal water supply is there, you don't have proper groundwater resources, or they are getting depleted. So that is why tank irrigation saves the places over there. So they supplement the water supply. That means you have the water supply, surface water supply, but yeah, tank water supplement. That means it is like an addition of the water you are having. Okay, and these are the reliable source that you can rely on these sources in the dry spells. Then it stabilizes the agriculture production. Why? Because whenever we have a high critical period, dry spells period, where canals are not full, river water is getting dry up, so you can utilize the canal water. It will help in stabilizing your agriculture production. Otherwise, it may get fall, right? So it reduces the risk of crop failure. Okay, and it is a boon to the smallholder farmer. It is a very big boon to the smallholder farmer, because tank water irrigation system is well suited for smallholder farmers. Smallholder farmers can have a small tank, they can dig up in their fields, and they can utilize it the water wherever they want, whenever they think that yeah, now it is best suited. Okay, because these small farmer may have their fields at a very remote places, they are not well connected with the canal system, they might not have a money to buy a tube well system, so they try to dug a small tank over there, which they helpful in irrigation their fields. Okay, so they can cultivate their crops throughout the year. Then conservation of rainfall, because this is a rainwater storage system. Rain water storage system it is, right? So we are calling as catch the rain, concept of catch the rain, wherever it falls. So tank will be helping us in following this campaign of rainwater storage. It will store the rainwater, and it will prevent the runoff, because if the water is not being stored, it will go runoff like this and soil erosion will happen. Okay, so it helps in prevention of soil erosion, it helps in recharging the groundwater, and proper soil moisture will be maintained. So these are the important things regarding tank irrigation. But yeah, and then It is low cost. You don't require very high cost. There is no high cost attached to it. You can just have some a few cemented and bricks, and you can make a tank system out of it, which you can utilize it wherever you want, and it doesn't require that much of maintenance. Okay, locally you can control, you can increase the capacity, you can decrease the capacity. So you have your own decision making in that. Okay, you are not dependent on somebody else, like shall we use, can I use that water or not, and when we can use, because in the canal, whenever the water will be released in the canal, then only you can utilize, right? Whenever the dams will be open, then only the water you can utilize. Okay, but in the tank system, it is your personal tank. You utilize it, you don't utilize it, whatever, it is up to you. Then adaptability. Tanks can be made anywhere, any type of land size, any type of topography. You just need a bricks and mortar, and you can just construct a tank over there. Okay, of any scale, small, big, medium size, whatever it is. Okay, so it, because of all these advantages, it gives a very good environmental benefit. Like it promotes soil conservation, it prevents soil erosion, it promotes water conservation. Near the tank area, you will have a enhanced biodiversity. Okay, you can find a lot of biodiversity at that places. And one more thing that I wanted to tell is it reduces the dependency on other type of sources. Okay, that means you have your own water. If the water is coming from the other sources, that is well and good, but if it is not coming, we are also having our own personal tank, right? Now with that concept, there are challenges also which are also being part of it. The most important challenge and the most severe challenge is siltation. Siltation means like years of use, there are sediments which get deposited. Like you have this tank. Okay, earlier you can fill this tank till here, but slowly the sediment started building on the bottom. Okay, sediment started building on the bottom. Now you can fill the water till here only. And if the sediments reaches till this level, now you can fill the water till here. So slowly years of usage, the silt gets deposited. Okay, so it reduces the storage capacity. It requires a regular maintenance, keep on removing the silt, keep on repairing the structure in order to make that function. And the gates, which were that sluice gates are there, which you have to need to open, you have to close it. That also need maintenance. Okay. Then climate change. Tanks are very good to store the rainwater, but actually the rain should also happen. There should be surface runoff. If rainfall patterns are erratic in nature, if there is an increase in temperature, okay, so you may not have proper supply of the water to the tank, and increased temperature will also lead to evaporation of the water. Evaporation is the general phenomena which is happening everywhere, whether it is ocean, whether it is river, whether it's canal, or whatever it is. Okay, then equity issue. Access to water from tank may not be always equitable. Sometimes it leads to the conflict also. Like if it is a common tank, if it is a common tank, then water usage, who will be using, how much they are using, that has a very big issue. Sometimes cultural issues are also there. People are bound to follow, these type of people cannot fill the water from here. Okay, so it was a very old age practice. Caste system practice also comes into place, right? So since India we are living, so we have to think of all these things. Like in the village area, what all issues can happen with the common facility of water. During earlier 100 200 years back, people of different caste are not allowed to take the water from the same well. Such an irony. Right now also in remote area, people are following these practices, but slowly it is going to be out when the government and when the law enforcement agency will be working. But yeah, the issue is there, and slowly it is getting solved. Now, what are the government has taken? What type of initiative? Government is running a very important program, integrated watershed management. Watershed management is an area from where, that is a catchment area from where you collect the water. So all the resources in that watershed area, whatever biodiversity, water, ponds, lakes, whatever are there, they are all included in that watershed area. Okay. So government is running integrated watershed management program in order to enhance the rejuvenations and restoration of the traditional water harvesting practices like taps. Manrega, sorry, here we have written Regas, we have Mahatma Gandhi National Rural Employment Guarantee Act. Okay, under that, government is asking the labor of Manrega to construct and repair the various traditional water harvesting facility like tanks and all these things. State level planning is going on where they have their own set of programs for irrigation and water conservation. And then after that, we are moving towards the new irrigation facility, that is wells. So well is also a very important source of irrigation. So well is normally known as a hole dug on the ground. Normally it is like ordinary well. It's of 3 to 5 meters. So 3 to 5 meters is now right a very far away point that we are asking, because right now no well is 3 to 5 meters. Right now the wells have to be dug very very deep because of the groundwater depletion. But if we go by the concept like around 3 to 5 meter deep, and sometimes it goes up to 15 to 20 meters deep. Okay, it's a hole that is dug, and very like thousands of years this concept of well digging is going on for taking out the water, lifting the water for drinking and bathing purposes, and also for irrigation. So normally where all these areas the well irrigations are there, normally whenever we talk like where exactly we find the well irrigation, it is a places where a lot of groundwater is there. That means the groundwater is at very upper level. It is at a very upper level. Okay, if the groundwater is at a very below level, then it is very difficult to dig a well, because they have to dig very deep down. Okay, so wherever the groundwater is at a very good level, upper level, though we can call, so that is why they are most popular at these places. Like we go to the northern plains area, Mahanadi region, Godavari region, Krishna, Kaveri. So from wherever the river is getting passed, rivers are getting passed who are having a good quantity of water in them, nearby areas you will find the water table very high. Okay, very high water table you will be finding. And in the southern area, if you go, if there are crystalline rock or sedimentary zones. Sedimentary zones are zones where water seepage happen. Okay, water seepage happens and water gets stored in the underground channels. Okay, there also you will be able to find, there at these places also you will be find that people will be utilizing the well irrigation properly. Okay, so the issue with peninsular India, why well irrigation is not suitable in the southern area, in the peninsular area and southern area, because southern area is a rocky area. So it is very difficult to dig that rocky surface, and it requires huge costing. It requires cost, it requires machines. That is why, and even if you utilize that, there is no proper groundwater storages. If you go like in the dry region of Rajasthan, some parts of Punjab and Haryana, we find there is a brackish groundwater. That means it is salty in nature, which is not good for irrigation, because brackish water is not good for irrigation. So at some places of Uttar Pradesh, maybe Western UP and Rajasthan and Punjab, which are known for their green revolution, the water quality of underground water quality has deteriorated. It is not of good quality. It is not of good quality. It is not there. Okay. Now, so, what are the merits of well irrigation? Obviously, it has a low initial cost, like you require very less money. Okay, simple machinery, less money. Simply, you can dug it manually also. So, normally it is good for the small farmer. Okay, and it is very suitable for where shallow water tables are. Shallow means like you can find the water table in 15-20 meters only. It is very good at these places, and the well do not require too much of maintenance. You can simply do a maintenance. Okay, you don't require much brain over that, right? So as compared to tube wells, wells require very less maintenance, because the tasks like maintenance tasks like cleaning and repair are very very simple. Okay, you don't require too much of cleaning and too much of repair, because during the time of foundation, the well has been dug up in such a way that automatically they have the proper safety zones that are being created over there. Then wells are suitable for a small area, like if you wanted to do agriculture. So a small and medium sized farmer, a small with the fields where small fields are small or medium fields are there. So it is very easy to dig a well, and it is very easy to irrigate the well using the irrigate the field using the well. Right now, people started putting generators in the well. Earlier, people used to do it manually. Earlier, used people used to do it manually. Now, people started putting a generator and just giving a touch of a tube well over there. Okay, so if you have a very small area, if you have a medium area, this well will provide you with sufficient water. Okay, that's for your localizing. And well also need very less energy. You don't require much energy for operation of the well. Okay, for water extraction you don't require too much of energy. If you require too much of energy, you have to pay too much of energy prices, so the cost of water extraction will become very high. So in this the one of the more merit of the well is you don't require too much energy. You require very less energy for water extraction, so the costing of taking out the water from the well is less. But if there are some advantage, then we also have some kind of demerits of well irrigation. Okay, too much digging, and everywhere wherever the people are digging the wells, it leads to the groundwater depletion. Continuous extraction without recharging, continuous extraction without the recharging. So whenever the rate of extraction of water increases, then replenishment, then the water table will go down, and after few years the water table will become dry and your wells will be dry. Okay, so this is the main cause why the wells are getting uh, drier in various metropolitan cities, because too much of extractions is happening and very less replenishment is happening, because the cities have become concrete jungles. So from the concrete areas of the city, the water cannot do seepage inside the ground. Okay, so since the water is not going down, but we are extracting the water at the same pace, automatically it is getting destroyed, right? Now, salination and water quality issue. First of all, we have to see where we are digging the well. Okay, from where we are extracting the water. Some places the water contains a lot of salts and various contaminations are there. Okay, so if you are extracting the water from there, it will automatically lead to the soil salination, and since the soil becomes salinized and the soil will have minerals in that, automatically it will reduce the crop productivity over a time. Okay, then energy intensive. How it becomes energy intensive is that because whenever you have water table far below 15-20 meters, that means you need pumping water set. Process of pumping will be required to take out the water. So this is an energy intensive process. You need motor to extract the water, right? You need motor to extract the water. So obviously this will increase your operational cost, and carbon emission will be very high, because since you will be needing pumping set, you will be firing diesel, petrol, automatically carbon emission will be there. Then well irrigation is suitable only for small scale farming. Okay, you cannot do a big farming using a well irrigation, and that is why the major limitation of the well irrigation is that it is only suited for the small scale farmer, because of the quantity of the water available and because of the distribution of that well. Now coming the tube well. Okay, so after the well, if you are going much deeper than that, okay, a tube well is a deeper well. A tube well is a deeper well, more than 15 meters if you are digging deep, and you are needing the pumping set to lift the water, or the electric motor to lift the water. You can see over here. So this is a well that we have dig, but it is well below the very below point we are finding the water. So we have to put a pumping set okay, in order to get the water. So automatically the diesel cost, engine, and various other things have got increased. Okay, so it is a deeper way. Slowly we will be also seeing like government has started one very important scheme that is called Kusum Yojana. That is the last part that we are going to discuss today in that. Okay. Now, tube well cannot be constructed everywhere. Obviously, tube well cannot be constructed everywhere because they have some geographical limitation. You have to see like whether there are proper sufficient water is there or not, whether like at what level the water is there, or are we going very deeper, are we going more than 50, 60 meter deep, because if we are going too much deeper over there, so automatically the advantage of running a tube well will go away. Okay, so because we have to see that wherever the tube well we are constructing, it should be in such a way that we can utilize that water for irrigation properly. Okay, so that if we are constructing a tube well where the soil is fertile, so we can use the water for irrigation and utilize it for increasing our farm productivity. But if you are constructing a tube well where the soil is not fertile, so there is no need, because automatically it will increase your operational cost and the cost benefit analysis. So cost benefit analysis of the tube well will go away. Okay, so you have to be very sure about the water, about the depth, about the cost and benefit ratio regarding the tube well. You have to keep all the calculation intact for tube well. Now, around three-fourth area of India is under the tube well, and is special, like not three-fourth area of India is well functioning under tube well, and majorly the tube well system are utilized in Tamil Nadu, Maharashtra, Andhra Pradesh, Telangana, Uttar Pradesh, Madhya Pradesh, Karnataka, and Punjab. These areas are extensively using the tube wells. Now, merits. Obviously, with the merit, we can go deeper. Okay, with the well, we cannot go deeper, but with the tube well, we can go deeper by constructing deeper aquifers, and we can go deeper into the water table and get the water from there. And higher water yields, because as we go deeper and deeper, we find a very big aquifers. Okay, deeper groundwater reserve we can take take the resources from there. Continuous water supply, since as we go more and more deeper, we have a very large reservoir of the water supply, of a reliable water supply will be there. Okay, that will be continuing our agriculture cycle. So in any of the dry season spills, whenever any dry season spills happen, so we can have a continuous water supplies there. Automation potential, yes, you can convert this tube well into a automation. Okay, right now there are a lot of work that is going on in like if I go in America, they are running their tube wells with the help of mobile apps. Okay, they are watching because they have 200 to 300 acres of field, so they cannot go and check everywhere. So they, what they do with the drone view, they check with the drone view wherever there is a dryness that is coming, they open the tube well of that place with the help of a mobile app, and automatically that tube well will start opening and start watering that field. So automation potential is also there, and automatically this will increase the water efficiency. We will be helping in properly utilizing the water, and efficiency of the water will also increase. And tube well is very important for large scale agriculture, because they require large quantity of water at regular interval of time. But there are some demerits also there, because it requires some initial investment, because you have to spend the money in building and in maintaining. So upfront cost is there: drilling, casing, equipping. Okay, all these things, it requires a good amount of investment, and regular maintenance and repairs are also has to be done in a proper way. And demerits are, if we are extracting water at that high pace, obviously it will lead to over extraction and groundwater depletion, and contamination will also happen. Potential water contamination happen because from where the water we are extracting, from there only contamination can also go. Okay, surface contamination can also go, saline intrusion will happen, surface pollutant can go and contaminate the water table, correct? So it will compromise the water quality. And dependency on energy, because we are totally dependent on electricity for running this tube well. Okay, so electricity we get from fossil fuel. Right now with PM Kusum Yojana, government is giving solar pumps to the farmers. Okay, so slowly that fossil fuel concept is waning away, but still it requires a lot of energy, and you require proper regular supply of energy. So it is not like for particular smallholder farmers, you cannot go and simply start doing that work. Okay, then limited access to equity issue. Obviously the person who is having a tube well and a person who is having only a well, so a tube well person will be much more powerful in agriculture field, because he or she will be utilizing it at his will with the power, and his field will get more extra water and at the cost of a person who is utilizing the well during that time. Okay, so marginalized people, small scale farmer, medium farmer, don't have resources to invest in the tube well, so they normally go for the traditional way of working. Okay, so this is the some of the demerits of irrigation using the tube wells. Now coming the canal irrigation. Now, canal irrigation, everybody knows it's a most widely used canal irrigation. Up to 1960, we have Indira Gandhi Canal, one of the longest canal that we have built in Rajasthan in order to provide the water at that place. But after 1970s, the well and tube well have become more used to it. Because why well and tube well have become more used to? Because they can be localized and they can be run at your own will. Okay, they can be run at your own will. But canal irrigation can only function when the government releases the water. Okay, when the government releases the water, and those people who are having their fields near the canals only, they can get the water properly, and the remote areas do not get proper canal water. So but still, after all these things, the canal irrigation is the second most important source of irrigation. Okay, so wherever there is a low relief is there, wherever fertile soil is there, where perennial source is there, that means water is present throughout the year. So that is very important. And wherever the huge command area means, if we have the water resource coming here from here also, and this is our canal, and water is coming from lot of sources. Okay, lot of sources, that means we have a huge command area means from where we can catch all the water of that whole area and channelize into a single way. There only the canal irrigation is successful. Okay, so main, that is why this canal irrigation has a main concentration at places like Uttar Pradesh, Haryana and Punjab. And during that time only they have done green revolution. Okay, they have done green revolution because government is supporting in 1960s this canal projects, right? So canal, then people say like, why we don't have canal system in the southern India more extensively than in the northern India. So it is very difficult to dig canal in a rocky and uneven surface. South India is normally a rocky surface, so it is difficult to dig a canal at that places. Okay, so that is why it requires normally loose soil, alluvial soil, where we can easily dig the canal. Okay, otherwise if you are digging the canal in a rocky places, uneven surface, it becomes uneconomical. Okay, so that is why they are practically absent in the peninsular areas, but you will find these canal area in coastal and delta area, because they have a soil which in which you can easily dig these canal. In the coastal areas and delta region like in West Bengal, Odisha, even in Maharashtra, Gujarat, you can find a certain degree of canal dig over there, but mainly the concentration of the canal is in Uttar Pradesh, Haryana and Punjab. So there are two type of canal system is there. One is concrete canal and one is inundation canal. Okay. So normally inundation canal, like if we have this river that is going on. Okay. If we have this river going on, right. So we take out the canal is taken out from the river without any regulating system. Okay. At their head. Okay, so they just simply take out like, okay, like this, from here we take out this, from here we take out this. Okay, so inundation canals which are taken out from the river without any regulating system. Okay, so they are called as temporary system. Temporary system. Okay, so whenever we have floods in the river, automatically the water start flowing in that. Okay, whenever we have floods in the river, automatically the water start flowing in that. And when we have a dry river, so automatically the level of water will go down in the river. Automatically the water will be cut in the canal system, right? So the canal will dry up. And again, when there is a monsoon and when there is a flood in the river, automatically the canal started working again. Okay, so it just based on the height of the water. If the water height is uh, up to, is above the canal, so water start flowing in that. But if the water height is below the canal, so water will only flow in the river. Then we have a perennial canal. Okay, so they are taken off from the perennial river in which water remains throughout. So if you go Farakka barrage is there. There are very big rivers are there, and the rivers water is diverted by having a barrages built. They build a barrage nearby the river and where they store the water, and canals are being dug out through these barrages. Okay, so Farakka barrage is there and various other barrages are there throughout our country where from the river which are having continuous flow of water, we cut the barrages. Okay, we take out the canal from the river and build the barrage over there to stop the water over there and put it into a canal. Now, barrage is what? It is an artificial obstruction placed in a river or water course to increase the depth of the water. Okay, that is the barrage. Now, wherever, at which places canal irrigation is prevalent? Normally, we have also discussed Uttar Pradesh, Punjab, Haryana, Rajasthan, Bihar, 60% water is there. In southern India, Andhra Pradesh, Maharashtra, Karnataka, Madhya Pradesh, Chhattisgarh, Odisha, Tamil Nadu, all these places are there where canal irrigation is most extensively used because of their local physiological setting. Now, there are some merits of the canal irrigation. In the canal irrigation, it provides efficient distribution of water, and that too proper water. You will get good water supply, good quality of water, because you can transport large amount of water over a long distance with the help of a canal. You have a stable water supply if you have a perennial canal. If you have a perennial canal, which you can see over here, we have a perennial canal. So if perennial canal is there, so you will have a stable water supply throughout the year, so that your crop yield will become consistent. Okay, so because of the canal, from wherever the canal is passed, you can see that at that places the fields are having 2-3 crops they are growing. Okay, they are growing 2-3 crops, and since canal is having a lot of water in that, you can grow high water intensive crop like sugarcane, rice, cotton. Okay, and if at any place there is a canal which is passing, automatically that area will become highly economically developed, because water supply is related to agriculture growth is related to increase in the economical activities. Okay, because it will boost the agriculture output, because this is the backbone of the Indian economy. So agriculture productivity will increase. The farmer will have higher income. Automatically, rural economy will stimulate, and obviously it provides you a food security. Then environmental benefits are there because it helps in mitigating the impacts of droughts and water shortages. Obviously, infrastructure, you will be building infrastructure nearby canals, because nearby canal you will be developing lot of infrastructure. It will provide a lot of jobs to the people in that area, because canal, you can utilize canal for transportations also, transportation of goods along with the people, and it will help in providing connectivity. Like if there is any village which is not connected with the mainland, okay, you can connect a canal over there. Canal will be utilized for irrigation water, for even drinking water also, and even for transportation also, okay. And canal provide equitable distribution because it is of the government, so government regulate the canal water. Okay, if managed properly, it can provide you with equitable distribution of water. But those people who have remote fields, remote area, in the remote area, because you cannot build canal everywhere. Okay, you cannot build lot of channels everywhere, right? So government intervention is needed in order to proper equitable supply the water. And historically, if you go dating back to around 5,000, 6,000 years back, you can talk about Indus Valley civilization, and Ganga canal system was there during that time. People were utilizing it, which shows that they were utilizing this canal system for irrigation, drinking water, bathing purpose, or whatever it is. Adaptation to climate change. We all know that climate change is a real thing. So we do not wanted our field to cry for water. So that is why canal based irrigation system, if well managed, it provides ample amount of water, and it will act as a buffer if there is any type of extreme events that happens, and it will provide more and more efficient distribution, more and more efficient supply of the water. Okay, and once all these things have been done, automatically it will support the rural livelihood, and it will boost the rural economy, right? But again, one thing has a positive point, then we have a negative point. Water loss because of the seepage and evaporation. Evaporation is a main enemy of the canal system. But now the government has come up with a very innovative idea. What we can do is we can put solar panels above the canal systems, so that we are getting the area also without putting solar panels and without buying the land. Automatically above the canal you can put solar panels, they will generate electricity also, and they will prevent the evaporation, right? And you will also not needing land for solar panel installation. So this is one of the most innovative idea. You can put solar panels throughout your canal system, right? And if it is well managed properly, so it is going to provide you with a lot of ample benefits. Seepage has to be seen every time, we have to keep on doing repairs work over there. Okay, so but sometimes the seepage and evaporation is so high that around 60% water is lost. 60% water is lost, especially in the canal system, because of seepage and evaporation. Sedimentation over years of use. Obviously, sedimentation is a problem of every place, even rivers, dam, seas, tanks, whatever it is, wherever you are storing the water, after few years, you will see the capacity of water holding will decrease because of the sedimentation below it. Okay, so that need to be regular drilling, proper maintenance, it has to be done. Then water logging and salination. Sometimes if the canal system is not managed properly, it leads to the water logging, and automatically it lead to soil salination. Okay, because you don't have proper drainage facility, and automatically the water will become too excess. It Because of that, water logging happens, and it will flood away the fields, and it will destroy the fields also, and it will decrease the soil quality. And since if there is too much water logging and salinization happens, it also reduce the agriculture productivity. Okay, and canal system has a unequal distribution, because you cannot make channels everywhere. So it has to go only through a main channel, and those people whose fields are near that main channel only, they get the maximum benefit out of it. Okay, and in the remote areas they are not able to utilize that canal system. Okay, now canal system is highly dependent on monsoon. Okay, because uh, canals are fed by the rivers, canals are fed by the dams. If the rivers and dams are not full, automatically the water will not be released in the canal. Okay, so if there is inadequate monsoon rain, if there is a water shortage, canal system will not work properly. Okay, then there is a lot of environmental impact, because it will disrupt the natural ecosystem. Okay, if you are building anything infrastructure, canal is a infrastructure, it may lead to habitat loss, fragmentation of the land, and it obviously do, it disrupt the natural ecosystem, it disrupt the habitat, it fragment the areas over there. High maintenance cost because they are of 100 of kilometers of length, so it requires high maintenance cost. And traditional canal system are now less efficient. You cannot simply release just the water and it will reach to the uh, it will reach to that place. Okay, so right now the canal system are very less efficient as compared to the modern technologies that are coming. We will be discussing what are the modern technologies are. Climate change vulnerability, because if there is high climate change that is happening, and if there is a change in the precipitation pattern, rainfall patterns, whatever it is, or if you have any kind of extreme weather events, you will not get proper regular supply of the water in the canals. Okay, and social intake, obviously it requires land acquisition. You need to displace the people from their places, so it causes social issues also building canal, because it's a huge project. You have to go from the fields, you have to buy the lands, you have to destroy some of the fields in order to build the canal. So there are all the social impacts are also there. Now we are moving to the next topic, which says that different type of irrigation system based on delivery, how we do the delivery of water. Okay, so based on that we have certain irrigation system. Okay, different type of irrigation system based on delivery. Okay, somewhere you have a surface irrigation, somewhere is sprinklers, drip irrigation, subsurface irrigation, central pivot irrigation, and manual irrigation. So we will be reading one by one. Surface irrigation is like flooding the field. Flooding. Okay, you can see here. Here the water is coming, and you have made some canals, small canals in your fields. Okay, so this is called surface irrigation. It goes through force of gravity. You do not do anything. You just simply make these channels, and automatically the water flows through gravity over there. It is also called as flood irrigation. That is called surface irrigation. Okay, so advantage of surface irrigation is it requires very less manual labor. Okay, and it will cover the large plot of land properly. You can see here in this example, you can see how this large plot of land is being covered properly by properly making channels everywhere, right? So this is called surface irrigation, a major advantage. And it is not being influenced by wind. That means if you are running the water on the ground, it will not, the winds and sediments will not affect. But there are some drawbacks related to this. Okay, sometimes you do over watering of the field. Okay, whatever the water is not even required, so it lead to wasteful consumption of the water. Okay, and if the soil is not having slope, if the water is not having slope, water will not move, and water logging will happen. Water logging will happen, and it may harm the crop. Okay, because you will, since the water will get filled in the fields, and the roots will not able to respire. And too much of water, if you are putting too much of water in the field, it leads to evaporation, and it may give lead to less of water. Okay, so percolation also happens, loss of water also happen due to evaporation. Then comes sprinkler irrigation. Sprinkler irrigation is a very novel technique, new technique, and it is also called precision irrigation, or precision farming techniques. Okay, so here we are applying the water that mimics the rainfall. You can see these sprinklers are there. They just blow the water like this. They blow the water like this. If you wanted to see, you can go to YouTube and you can find how the sprinkler works. You will see that they just throw the water like this. Okay, so with this you can see that the distribution of water will be very it will be sprayed in the air. Okay, into small drops. Okay, small drops will be sprayed into air and into the field. So they will have a very small pipe system, a small pipe system from where a small amount of water will come, and that will be spread in the form of a rainfall into your field. So advantage is uniform water distribution will happen, because it will cover whole field in a proper way. Okay, So uniform coverage will happen. Water loss will be reduced because we will be utilizing very less water. Okay, if we compare with if we compare with the surface irrigation or any other irrigation, it will lose, it will prevent a lot of evaporation. There will be no runoff, or there will be very less runoff. Okay, so better water efficiency, flexibility. You can keep this system wherever, any terrain. You can take it to the hilly terrain, you can take it to the ground terrain, you can take it to uneven terrain, wherever you want it to pick. You can just pick and you just put the system over there and automate, and it will start working there. Frost protection. In cold climate, a sprinkle system used to protect crop from the frost. Okay, by creating layer of ice that insulate them from the freezing temperature. That means this sprinkler system will create a layer of ice so that the outer freezing temperature will not affect the plant, and it is easy to automate. You can use timer in that, sensor in that, controller in that. Okay, right now people are utilizing these sprinklers even in their gardens, small gardens at their homes. Okay, some of the disadvantages in the high upfront cost. Very high upfront cost is there, you need to pay a lot of money. Okay, so because of that, it may deter some farmer to go with this sprinkler system. Then energy consumption, it requires energy to operate. Electricity you need, so you need electricity for distribution of water, and if it has to be done at a higher elevation, so you need more powerful sprinkler. So more and more powerful, more and more better and powerful motor you will be needing for this whole purpose. Okay, potential of wind drift. Wind drift means, what I'm saying is that when the sprinkler is spraying the water, there is a wind that is blowing, it may take the water along with it. It does not happen with the surface water, so that is why wind does not have wind does not affect the surface water. But if you are sprinkling the rain, like a small droplets of water, the wind will take away if there is a very high wind. Risk of disease spread. Sometimes the sprinkler can spread the diseases of plant by splashing water on the foliage. There is a foliage or a material that is there, it may lead to the spread of diseases, because you will be providing a very good environment for the grown of these diseases. High maintenance requirement is there, because you have to keep on cleaning the nozzle, proper functioning, checks of the leaks, repairs and damages, so it requires some costing for running a sprinkler machine. Then we are coming into a drip irrigation, a very important irrigation system, drip irrigation. So in the drip irrigation, you can see it is called as trickle down irrigation, trickle down. Okay, so here the water is delivered near the root zone or on the surface of the plant. Okay, if this is a plant, so we will drop the water over here, not directly to the roots, but on the top of from where the roots can easily pick drop by drop. Okay, so that is why it is called as a most water efficient method of irrigation. So it is one of the most water efficient method of irrigation. If you are able to manage it properly, it will prevent the evaporation to a large extent, and runoff will be minimized, because whatever the water is needed, the roots will be absorbing it and there will be no runoff, and you will see that only a certain degree of the field will remain wet and rest everything will remain dry. So only what is needed, how much is needed, is only supplied over there. Okay, now today's irrigation, drip irrigation system is combined with plastic mulch. Okay, so near this field you can see there is a plastic mulch that they will put to reduce further evaporation, so that moisture of the soil remain intact, and it is also means of delivery of fertilizer. Like if I tell you, like these are the pipes, like if this is a crop, okay, this is a crop, and from here these pipes are coming. Okay, so you can deliver the water also from here, you can deliver the liquid fertilizer from here. You can also deliver the liquid fertilizer from here. So optimum use of fertilizer will also happen. So this process is also called fertigation. This process is also called as fertigation. Then advantages of drip irrigation is obviously water conservation, prevent evaporation and runoff. It will help in preventing the water. Efficiencies will be manifold increase because precise application of the water, proper adequate moisture will remain over there without wastage. Reduce the weed growth because since we are only giving that much of water which is required by the plant, so only target a specific area around the plant has been given, so there will be no unnecessary growth of the weed, because if we try to flood the field, automatically the weeds will grow, right? So that is why we don't need herbicides and manual weeding. So again, it reduces the cost. Okay, minimize the soil erosion since we are only supplying drop by drop water to a plant roots, so there will be very less water, so there will be no runoff, there will be no surface runoff. If we go by the surface flooding, there will be surface runoff in the sprinklers. Sometimes sprinklers may also dislocate the soil particle, but your drip irrigation will not replace the particle there. They will be only dropping the water, the soil will remain intact over there. Okay, it can be highly customized and accommodated as per your need and as per terrain. Okay, you just only have to put the pipes over there, right? Plastic pipes are there which are flexible in nature. Okay, so you can put it over there, so they have this advantage. Again, the disadvantage that are coming under this field is they have a high initial cost, very high initial cost. You have to fit it with tubing, emitter, filter, valve and everything, so they have a huge high costing is there. Then clogging means since these pipes are having holes, so they need regular maintenance and they keep on going clogging because of the soil, because of the fertilizer particles in that. So we need to do a proper flushing and installing filters in that. Okay, that requires again costing. Dependency on infrastructure because you need emitters and you need a network of tubing and everything. Okay, so wherever you go, you need those tubes, you need those emitters. Okay, so sometimes they are being damaged by the human activities, sometimes by the pest, sometimes by the natural events or something like that. So maintenance is a huge in this, maintenance cost is high in this. Skill is needed for proper functioning, skill is needed for proper functioning because simply nobody can run this drip irrigation plant. So people have to have a knowledge and expertise in the running, like what is, like how much we have to provide, how much fertilizer have to send. Okay, so you have to know proper quality of water, proper quantity of the water, all have to be has to be done in a proper way. Otherwise, if you are not knowing anything, automatically you are destroying the crop health. It has a very limited coverage area because it is best suited for row crops. That means the crops which are grown in a rows, okay, or orchards or garden beds or uniform spacing places only. It has a availability and application over there. Okay, but it is not at a places where mixed type of farming is utilized and all those things. So here, where something is very uniform is there, there only you can utilize all these things. Okay, as a, but that is why it has a very limited coverage of drip irrigation. Now we are coming into the subsurface irrigation. Okay, normally people ask, sir, what is the difference between subsurface irrigation and drip irrigation? In subsurface irrigation, we are also sending the water to the roots. There is a difference between drip irrigation and subsurface irrigation and subsurface irrigation. Drip irrigation leaves the water on top of the soil, and in subsurface irrigation we are sending the water directly to the roots of the plant. ड्रिप इरिगेशन में टॉप ऑफ द सॉइल में रहेगा और सर्फ सरफेस में रूट्स में जाएगा. ओके, सो water through the tubes and emitter, you can see over here other, if drip irrigation was there, so we put it over here. In subsurface we are sending the water through the root system. Okay, in 1960 it was developed in Israel because you know Israel is a water scarce country and they have a very hot, arid and windy climate is there. So subsurface irrigation is very important in order to prevent the evaporation. So water evaporation will come down. weeds will come down because you are not providing water to the surface and you are only providing water to the root surface. So normally the weeds germinates on the top of the crop. The weed do not generate in the root. So what we are providing the water in the root, so there is no water for the weed, so weed will not there. It will prevent the damage from the animal or machinery because system is below ground. So that is why it will also prevent the soil erosion because surface runoff will not be there. So this is called subsurface irrigation. Then central pivot irrigation. Central pivot irrigation means there will be a central pivot that will be kept. Okay, self-propelled system in which there will be a single pipeline. There will be only a single pipeline and there will be a row of mobile towers. Pipeline will be one and you will have a row of mobile towers. So, and these mobile towers, they have a tire between them. The mobile towers have a tire in them. Okay, so these are being 2 to 4 meters high. Okay, you can see over here, I'll just show you in the diagram. This is a single pipe that is coming, and these are the mobile tower. These are the mobile tower. Empty mobile tower, mobile tower, mobile tower. Okay, so they are suspended 2 to 4 meters high. Water is pumped into this tube. Water is pumped into this tube and the tower is rotated slowly around the pivot point. Okay, like that, in a round circular way. So this sprinkler nozzle will be working. So people will ask, sir, what is the difference between sprinkler and then central pivot? Central pivot is for a, like, it's a single tube that is going on, but in the drip in the sprinkler system you have a lot of tubes that are coming, and in this they are spraying the water. Okay, so water is distributed through a pipeline under pressure when the pipeline rotates, and this nozzle are graduated small to large so that fast moving outer circle receives the same amount. Okay, so it rotate in such a way that every part of the field gets the water exactly the same amount as the inside they are getting the water. Okay, so this is called central pivot. You keep a central pivot and you start rotating that in a circular way. Okay, so advantage is uniformity, no human labor, lower pressure it can operate, so it will conserve energy because you do not require much pressure on that. It will reduce the opportunities for surface runoff, so there will be very less surface runoff because again it is a precision agriculture. And you can also file fertigation, that means you can also supply fertilizers from there. Okay, you can also supply the fertilizer from this central pivot irrigation. But disadvantages obviously has a high capital cost. Energy is required for running this whole system. Obviously electric and diesel motors and generators will be required. Operation and maintenance, because you need a skilled person to deal with this. A person who don't know how to operate, how much to operate, how much fertilizer, how much water has to be released, the person will not be able to. So they require a different set of skills for functioning. Okay, and it is not suitable for irrigation of field of rectangular or square in shape, because otherwise it will be less efficient. It is only for a field which is circular in shape. So whenever this pivot will be revolving, it will be revolving like this. But if you have a regular or this field, so this pivot will be leaving certain places of irrigation. Okay, so that is why especially for circular field this pivot center irrigation is utilized. Now manual irrigation. Manual irrigation is something where you have to go and manually you have to deal with that. Okay, it is highly labor intensive, right? You are so it is for only a small and medium field. Okay, small and medium field, even you do not keep medium in that, only very very small field, because you have to utilize either bucket or either cans to flood the water. Okay, normally in the rural area which are very very small field, very very like subsistence field they are having, they utilizes this manual irrigation technique. Now we are moving towards the next topic of discussion. classification of irrigation projects, and then we will be discussing about some of the schemes. So in our India, we have three important classification of irrigation projects. Some irrigation projects are very, very big, massive scale irrigation projects. Normally, you can call them as a canal system, or you can call them as a dam system, okay, which requires huge water for irrigation. Normally, they are going to cover around an area of over 10,000 hectare. That if any project who is going to cover around 10,000 hectare area or above that of irrigation, we put them under the major project or major irrigation project. Then if it is from 2000 hectare to 10,000 hectare, we put them under the medium project. Okay, so we can put them under the check dams are there, okay, small dams are there, okay, embankments are there, small irrigation projects are there. Then we have a minor projects are there, which are irrigating below 2000 hectares. Okay, so they can be do irrigation with the help of well, tube well, surface water irrigation, or gravity tanks. Okay, so minor projects are many, and it is normally for a small and marginalized way of irrigation. But for large areas, very big areas, you require a major project where 10,000 hectares of land will be utilized for irrigation. That is called major project. Then if 2000 to 10,000, medium project, and if it is below 2000, it is called minor project. Now under major and medium irrigation, major means above 10,000 and medium means between 2000 to 10,000 hectare. They are further classified like under this major and medium what type of irrigation that we are going to use. So we will be either using the direct irrigation method. That means from the source only we can directly put into the irrigation. Like if we have a project water, in this project water is directly diverted from a river into a canal. Like if river is going, directly we are diverting the, like if we say Ganga river, okay, we have a barrage over here and we are converting them into a canal. Okay, so we are directly transferring the water from river to directly to the canal. So there is a construction of diversion like barrage. Okay, we call that as a Farakka barrage. Okay, so the water is transferred from Ganga to the canal. So that is called direct irrigation method. Okay, then there are some storage irrigation method. Storage means you store the water, maybe from runoff, maybe from monsoon, maybe from melting of the ice. Okay, you store that in certain reservoir and you can utilize it whenever you need. So under this storage irrigation system, we put dams under the storage irrigation system. Okay, so dam is a, what is a dam now? Dam is a hydraulic structure constructed across a river, and based on the structure, like how the dam has been built, there are four types of dam: gravity dam, buttress dam, earth dam, and arch dam. Okay, slight difference is there. We don't have to dive into like functioning of a dam or something. We just have to know what is a dam and how many type of dams are there and what is the use of that. So gravity dam, these dams are heavy and very massive. They are made from concrete. Heavy concrete is utilized, and their weight and the weight of the water is vertically downward. Whole weight are at vertically downward. So these dam resist the horizontal thrust of water because of their weight only. Okay, water, like if we have this dam is there, water is here, so water is pushing this horizontally, right? So dam concrete wall is protecting them. Okay, so here if you go and see, we can call this as a concrete or gravity dam, we call it as. Okay, then we have buttress dam. It is a gravity dam. It is also a gravity dam reinforced by structural support. Reinforced by structural support. On the sides, series of buttress are there. Like here you can see. Uh, in this you don't have buttress. Buttress are these things. These things are called buttress. That means They are supporting the dam. Here water is filled and water is continuously forcing here. So these buttress are providing additional support to the dam. Okay, these buttress are providing additional support to the dam. So this is called buttress dam. Okay, then we have earth dam. Earth dam means they are trapezoidal in shape, and they are mainly used and they are mainly made from the local available material. Okay, they are made from the rock, they are made from the underlying material, whatever is there. That means they are of weak support. Okay, these dams are weak in nature. That is why they are not allowed to carry heavy water in them. Okay, so these earth dam are of low capacity value. They have a very low capacity value, and they are being made only from the local available rocks and materials which are there. Then we have a arch dam. Arch dam, if you see over here, so this is an arch dam. Okay, in the form of an arc it has been built. Okay, so these are designed so that the force of the water against it is known as hydrostatic force. So pressure against the arch, compression and strengthening the structure is pushed into the foundation. Okay, so it reinforces the whole arch with the use of water itself. So this is called arch dam. So you just need to know what type of dams are there, nothing more than to discuss in this. Now there are some other type of other storage system are there. Spillway and energy dissipator. You know, around the dam, when dam gets filled up, where the extra water will go, there is a spillway that has been created which carry the excess water over and around the dam. So here we need an energy dissipator device which is used to convert concentrated storm water runoff to sheet flow. So we need a water which converts, like storm water will be very, very volatile. So we need to convert them into a proper sheet flow. Okay, and then it is stored at certain place. And then we have a sluice and outsill. Okay, sluice is an artificial channel for conducting water with a valve or a gate to regulate. So अब जैसे like this we are having, like water is filled over here. Okay, so this is a gate. This is a gate. We call it as a sluice gate. Okay, you open the gate, water started flowing over here. You close the gate, water will stop flowing here. Okay, so this is an outlet which is very small structure which admits the water and send the water into the channels. Okay, so this act like a head regulator, channel regulator for irrigation fields. So this sluice outlet can be very big outlets, it can be very, very small outlets. Okay, only this much you have to know from here. Now we move into the some very important scheme related with irrigation system, and these are the top two schemes which government is running for, especially for irrigation areas. That is Pradhan Mantri Krishi Sinchai Yojana (PMKSY), Kisan Urja Suraksha Evam Uthan Maha Abhiyan, that is Kusum Yojana. Okay, so these two schemes we will be discussing in details today. Okay, so let's start with the first one, Pradhan Mantri Kisan Sinchai Yojana. Okay, the main focus area of this scheme was convergence. Convergence of various other irrigation scheme into a single scheme. Okay, so to provide a good amount of assured irrigation, improved on-farm water use efficiency to reduce the water wastage, and proper adoption of the precision irrigation. That means we wanted to make more crop per drop. Okay, we wanted to properly optimize. We wanted to properly optimize the use of water so that each and every water drop we can utilize. That is why this new scheme, Pradhan Mantri Krishi Sinchai Yojana, has been launched by amalgamation of various other schemes. Okay, so it is an amalgamation of various schemes like Accelerated Irrigation Benefit Program (AIBP), This has been run by Ministry of Water Resource and River Development and Ganga Rejuvenation. Then Integrated Watershed Management Program IWMP of Department and Land Resource, and on-farm water management of the Department of Agriculture and Cooperation. So this is an amalgamation. Pradhan Mantri Krishi Sinchai Yojana is an amalgamation of the ongoing scheme. So various ministries are there: Ministry of Agriculture, Ministry of Rural Development, Ministry of Land, Water and Degradation, Ministry of Water Resources, Rural Development. Okay, so they will all take various measures. They will all create and devise policies for the irrigation. They will construct the diversion channels, field channels, water division. Everything will be created in order to develop the irrigation system holistically holistically, so that we are not working in silos. We are working in an integrated way so that proper functioning of irrigation can happen. Okay, so Pradhan Mantri Krishi Sinchai Yojana focuses on decentralized state level planning. Now, so this is following a decentralized state level planning where a state will be making their own plan. They will be making their own irrigation plan, and they will be taking the help of district irrigation plan. Okay, so it is like a decentralized planning. So state will be making plan with the help of district irrigation plan, and they will be sending the plan to the central government. So there will be a state level committee, there will be an interministerial committee, and there will be a national executive committee. So state level committee will be checked by the chief secretary, and the program will be supervised by the interministerial national steering committee, and there will be a national committee, and it will be constituted under the chairmanship of vice chairman of the Niti Ayog, right? So there are a lot of components under this. So there are total 4 components are there. So component 1 is accelerated irrigation benefit program, AIBP. The purpose of this is to foster completion of major and medium irrigation projects. So wherever the faster and major and medium irrigation projects are going on, we have to do the faster completion of that. Okay, that is the first focus area of Pradhan Mantri Krishi Sinchai Yojana. Then second one is Har Khet Ko Pani. Har Khet Ko Pani, that is the second component. That means we need to provide water source through minor irrigation, whether surface or whether ground. Wherever there is a repair is needed, repair has to be done. Wherever restoration is needed, restoration has to be done. Renovation. Okay, so carrying capacity has to be increased. Command area develop, proper catchment area has to be developed in a proper way, with a better utilization of distribution networks. Okay, water management and distribution system has to be well developed in a proper way, and at least 10% of the command area will be covered under the micro precision farming. So wherever this process is going on, 10% of that command area has to be covered under micro and precision irrigation. Okay, and from various places diversion of water has to be taken from the, like, plenty of water is there. You can utilize the lift irrigation system wherever any low elevation is there, and you can utilize the Manrega labor for this whole process. And you can also create rejuvenation of traditional water storage like Jal Mandir in Gujarat, Khetri, Pool in Himachal Pradesh, Jebo. So these are all the traditional water conservation method that utilize. So these are some of the local name like Jal Mandir, Khatri and Pool in Himachal Pradesh, Zebo in Nagaland, Eri Orians in Tamil Nadu, Dongs in Assam, Katas and Bandhas in Odisha, MP. All these things are there which you can utilize in this. Okay, component 3 is watershed development. Watershed, like water harvesting facility. You can create check dams, nala band you can do, farm ponds and tanks. So like you have to develop a proper watershed, like all the catchment area, watershed development, all the water sources from wherever the water is coming, you have to collect that. You can create the check dams, you can create the nala bunds, farm ponds, all these things you can create, and you can proper create a entry point activities so that water and water like the focus area is soil and moisture conservation. Nursery raising also you can do, afforestation activity you can do, watershed development, horticulture, pasture development. All these things has to be done because this will help in water conservation methods. Okay, rainfall management activities, field bunding, contour bunding, trenching, all these things has to be done under the watershed program of Pradhan Mantri Krishi Sinchai Yojana. And the fourth component is per drop more crop, Department of Agriculture. Okay, so this program management has to be prepared by state and district irrigation plan. Water efficient process has to be used. How? Per drop more crop, we can go with precision irrigation techniques. With precision irrigation techniques like drip irrigation, sprinkler, pivot irrigation, rain guns, and everything. Okay, so we can utilize the Manrega activities. We can join lining, inlet, outlet, silt traps. Everything can be utilized. We can utilize the Manrega labor for properly running this precision irrigation techniques. Okay, so you can dug a tube wells. You can dig the wells over there. All these things will be utilized for per drop more crop. That means precision irrigation technique has to be adopted under the component 4. Okay, so there are certain more things are there under per drop more crop, is that secondary storage structure has to be built properly so that rainwater and storm water can be collected. Water lifting devices like diesel, electric, solar pump has to be included in that. Promotion of scientific moisture conservation technique has to be followed. Capacity building at each and every level, has to be followed. Generate awareness in whatever the way possible with the help of technologies, organization, workshop, conferences, whatever it is. You have to generate the type of awareness among the people. Okay, and then also use improved and innovation technologies and distribution system, and use out of the box experimentation for running this per drop more crop system. Okay, so district irrigation plan and state irrigation plan, they will be identifying the gaps under that. Okay, they will be creating the total plan, and they will be sharing with the central team. And central team, along with various schemes that are already running like Manrega, Rashtriya Krishi Vikas Yojana, Rural Infrastructure Development Fund. You can utilize the fund of the Member of Parliament. You can utilize the fund of the MLAs. Okay, all these fund and all these services and all these schemes will be utilized for proper functioning of Pradhan Mantri Krishi Sinchai Yojana. Okay, so district irrigation plan will create a holistic irrigation development perspective, because these are the last mile connectivity. They will take all the decision, and they will be taking all the help of the participating department. Okay, so DIP may be present at 2 level. You can go for a block level, okay, irrigation plan, or you can prepare for a local level irrigation plan. And based on the priority, if you are doing a block level plan, then you can be take the help of the nearby areas. Okay, if you are making any planning, based on the basin or sub basin level, so you have to do a comprehensive irrigation plan, because you have to include more than 2 districts, 3 districts. How many districts are there? So if you are making a basin level plan, you have to include 3 4 districts in that. Okay, so like that you can utilize the satellite machinery, topo sheets, and everything you can utilize in order to gain the importance, and in order to get the better functioning of the Pradhan Mantri Krishi Sinchai Yojana, and targeted implementation of a scheme will happen over there. Okay, so we have already discussed state level steering committee, national level steering committee, and national level we have a Niti Ayog, a vice chairman will be there, and the national level we have a national steering committee that will be there, and state level we have a chief secretary who will be supervising this whole work. Okay, so we have a 3 things: Ministry of Agriculture and Cooperating, micro irrigation program, per drop more crop. Under the accelerated irrigation program, we have to finish all the major medium national projects, right? Command area development, we have to do repair, renovation, restoration of the working bodies. Har khet ko pani is another topic over here. So this is like a summary. This is like a summary. Okay, then Ministry of Rural Development, integrated watershed management program, and you can utilize the Manrega worker for proper watershed development of that area. So this is how you can just explain that in your examination. Okay, so program design is state level, they will make projects. Then state level project steering committee, they will make state irrigation plan. And district level, they will make annual irrigation development plan. So this is how we do the convergence. Okay, so all people have their own special task in their hand, and this is how the convergence will happen. Now we are moving to one of the most important in the next scheme, that is called PM kusum. Okay, kisan urja suraksha evam uthan maha abhiyan, PM kusum, was launched in 2018 and 19. The main task, the main aim of them is to incentivize the farmer to run solar farm water pumps. Okay, if farmer is having barren field, so they can use their field to set up a solar plant over there. Okay, along with that, government will incentivize the farmer for solar farm water pumps for their barren land, and they can generate the solar power and they can get the extra income. So government is investing around 1.4 lakh crore in this whole activity. Out of that, 48,000 crore will be financial assistance will be given by the central government. So under that PM Kusum Yojana, we have three components are there. And the all the three components have to add solar capacity of 34,800 megawatt by 26th March. So sorry, March 2026. Okay, so three components are there. First component is setting up of 10,000 megawatt of decentralized ground stilt mounted grid connected solar. Second one is component B, where we will install 14 lakh standalone solar pump. Standalone, these are not grid connected. Component C is solarization of 35 lakh grid connected agriculture pump, including feeder level solarization. Okay, so this all has to be done by 31st March 2026. Okay, after three more years are there. So component A is solar energy based power plant. We have to make, like, if you have a barren field, for 500 kilowatt to 2 megawatt solar power plant, you can put, either you are individual farmer, group of farmer, or cooperative, or panchayat, whosoever you are, you can set up this. Okay, and government will provide you subsidy in setting up of this. Okay, so you will know, like discom will notify the substation like surplus capacity which can be feed directly into the grid. Okay, so this is for extra income generation. So 500 kilowatt to 2 megawatt, if you have a barren field, you can put it. Then component B is that stand alone solar agriculture pump. That means those farmer who are in the remote areas, those who do not have connectivity of canal system, then they don't have connectivity of the tube well, all, so they can set up a stand alone solar agriculture pump. Okay, so that pump will be working on solar energy, and the capacity is up to 7.5 horsepower in off grid areas. That means where grid supply is not there. So these are the technical terms. Okay, CFA of 30%, cost of tender cost uh, will be there. Okay, so the state government will give at least the subsidy of 30%. Okay, and remaining at most 40% will be provided by the farmer. Okay, so bank will be financing the farmer in the later on stages, right? So, and for northeastern Sikkim, Jammu Kashmir, and Himachal Pradesh, this percentage is being different as per the requirement, whether they are the backward state, whether they are the advanced state, or whether they are very very backward state, like that. Okay, then we have a component C, that is individual pump solarization. Okay, so individual farmer having grid connected agriculture pumps. Okay, so here the farmer will be having a grid connected. That means that solar PV capacity up to two times of the pump capacity. So here you will be used to generate the solar power. You can get your irrigation need, and whatever the extra solar energy that will be produced, you can sell it to the discom. Okay, you can sell it to the discom. Again, state government will provide at least subsidy of 30% in that. Okay, and in the northeast and Sikkim and various areas, this percentage will keep on varying based on the type of government way of working. So in the exam you don't have to remember this data. You just have to remember what all the components are there, because you have only 250 words to write. So how diversified you and write an answer, that depends on whether you understand the requirement of the questions or not. So you remember how many components are there, what is the role of each component, what it is going to do in the near future. Okay, so this is all about the PM Kisan So PM Kusum Yojana. So this is a dashboard. This is the dashboard that government has running, okay, for component A, for component B, and component C. You can see it is day-to-day monitoring that is happening. Every day the monitoring is happening. So total sanctioned solar capacity is 4,760 watts. So right now they have got 165. Here standalone pump installed, total sanction is 12 lakh 94,787. But right now how many are there? 2 lakh 98,270. And total sanctioned individual pump are 1,61,204. But right now how many installed are 2,538. So by 2026 we have to achieve this target. We have to achieve this target altogether. Okay, so this is a dashboard that government has created especially for this whole mission. Now we are moving on to some of the previous year questions of the UPSC. I have taken only few questions and I will be discussing only a single question here. So I will be telling you how the requirement, how the question normally been asked from this whole section. So since we are talking, we are discussing the topic on irrigation. So we can say in what ways flood can be converted into suitable source of irrigation. Okay, and all weather inland navigation in India. And second question, what is the water use efficiency? What is the meaning of water use efficiency? Describe the role of micro irrigation in increasing the water use efficiency. Then third one is, what is allelopathy? Discuss its role in a major cropping system of irrigation. So you can see like all these things are catering to certain degree of points and they have certain degree of commonness in the answer, but you just have to write a slightly different way of answering it. Okay, so I have selected this question, in what ways flood can be converted into suitable source of irrigation and all weather in navigation. So you have to start with the introduction. You have to start with the introduction, like flood often used as a disaster, can intent be harnessed as vulnerable. So in the starting, you have to give what is the flood and what happens when the flood comes. Okay. Then in the topic statement, when the topic statement come, like now you are doing transition. Now you are doing transition. Then to convert the flood into suitable source of irrigation, what we can do here. So that is what how we are going to answer now. Then this is how we start with the topic statement. Then after that, like how we can convert the flood into a substantial source of irrigation. So first what's the point is, reservoir and storage facility has to be developed. Okay, so if you wanted to catch the water of the flood, you have to develop the reservoir and storage facility, okay, that can capture the excess flood water during the peak period, right? Then you have a separate canal system and irrigation network, like how you can utilize this after reserve, after you are keeping in the reservoir. How you are going to utilize that water? It is by developing the extensive canal system, okay, so that it can, we can send the water to the agriculture field efficiently. Okay, that is the second point. Then floodplain and management. Whenever we are talking about like flood water, so we have to catch that water in a proper way. So how we can catch? With the help of afforestation, wetland prevention we can do, absorb excess water during the flood, and storm drainage water has to be properly done. We have to provide the replenishment, like groundwater seepage we have to provide at various places. Okay, so all these eco-friendly measure we have to utilize, then only we can utilize the flood water in a sustainable way. And then hydroelectric projects, so irrigation flood control measure with hydroelectricity projects. So whenever we have excess of water during the flood, we can utilize it for power generation. Okay, we can channelize that water because dams are there, right? Dams stores a lot of flood water. Okay, so it also help in flood mitigation. Dams help in flood mitigation. At the same time, they also generate the electricity from that. Okay, modernization of the waterways. Okay, you can upgrade the existing river system and waterways with modern navigation infrastructure. Okay, so proper new like lock and dam system, barrages system. Okay, so that water should be stored in a proper way and water should not get wasted as a flood water. Okay, then community based flood preparedness, like we have to make the community participate in the flood management practices. Early warning systems are to be there, emergency response training system has to be there, embankments has to be created so that sudden runoff should not happen. Okay, so after writing all these points, you can see this is a very holistic answer where each and every aspect where each and every aspect of that answer has been covered properly. So this is how you will be able to write the answer, and this is how you will catch the examiner attention in the examination, because you are writing in a holistic and generalist way. Since you are preparing for a UPSC examination, it is a generalist post. So you have to think from each and every perspective. And after that, once you have catch on all the perspective and properly highlighting that I'm writing all these, you have to give a very balanced conclusion. You have to give a very balanced conclusion, like by adopting these integrated approaches, flood in India can be transformed from destructive force into a valuable resources by proper transportation channel, and it will help in proper agriculture productivity, economic growth, and resilience to the climate change impact. However, careful planning, sustainable practices, and stakeholder engagement are essential. So here we have given the uh, positive note, positive note with the help of the stakeholder duties. Okay, so we have chalked down everybody in this whole answer. So the answer, it's very integrated, like it is very holistic answer, like everybody is integrated in this answer, and it is a very holistic answer in which you can see each and every aspect of this flood water has been covered. Okay, so guys, this is all for today. Thank you so much. I'll be coming with the next topic in the next class. So till then, bye bye, take care, and have a good